Assalamualaikum and selamat sejahtera. So firstly, I would like to introduce myself first. My name is Shafiq Ahmad bin Rosdi. My matrix number is 08DKA21F2078. So I would like to introduce my group mate. Firstly is Muhammad Iman Rafiq bin Abdul Wahid. Second is Muhammad Nur Irfan bin Bukhari. Third is Muhammad Alif Daniel bin Khairul Azman. And lastly is Nur Atika Nadia binti Aslita. So we would like to presentation and explain about application of differentiation and rate of change.
Applications of differentiation. Differentiation is widely used in science and engineering field. It can help us solve many types of real-world problems. Some applications of differentiation include tangents and normal, Newton's method, rate of change, finding maximum and minimum points, and curve sketching. Example applications of differentiation on real life. Number 1 is to check the temperature variation. Derivatives are used to derive many equations in physics. Number 3 is to calculate the profit and loss in business using graph. And lastly is to determine the speed or distance covered, such as miles per hour, kilometer per hour, and others.
Stationary. A stationary point of a function fx is a point where the derivative of fx is equal to 0. These points are called stationary because at this point, the function is neither increasing nor decreasing. Graphically, this corresponds to point on the graph of fx where the tangent to the curve is a horizontal line.
So now I will talk about stationary point. There are three types of stationary points. Number 1 is maximum point, second is minimum point, and last is inflection point. At maximum point, if a maximum is located at the top of bit on the curve, while minimum point is at the bottom of the true. Last is inflection point if f prime x is equal to 0, then the point is a dictionary point of inflection. So next, to determine the stationary point is a maximum, a minimum, or a point of inflection, we must apply the second order derivative. If d2y per dx2 more than 0, it is a minimum point. If d2y per dx2 less than 0, it is a maximum point. If d2y per dx2 equal 0, it is a point of inflection.
Example of stationary. The question is, find the stationary of the curve y equal to 2x squared minus 12x plus 4. Firstly, you must change the position of the power and put on in front. The first step is dy per dx equal to 2 bracket 2x squared minus 1 bracket minus 12 1 minus 1. Next is dy per dx equal to 4x minus 12, and then 4x minus 12 equal to 0, and then 4x equal to 12, and x equal to 12, you must divide by 4, and the answer of x is 3. The next step is y equal to 2 bracket 3 square bracket minus 12 bracket 3 bracket plus 4, and the answer of y is negative 14. And equation is x equal to 3 and y equal to negative 14.
Rate of change refers to how quickly something changes over time. It is the acceleration or deceleration of change and not the magnitude of individual change themselves. In finance, rate of change is used to understand price and identify momentum in trends. How to find rate of change? To find the average rate of change, must divide the change in y value by the change in x value. Find the average rate of change is particularly useful for determining change in measurable value like average speed or average velocity.
Okay, how to solve rate of change problem? So, rate of change problem can be generally be approached using the formula R equal dt, or rate of change equal the distance travel divided by the time it takes to do. Depending on the context involved in the problem, distance can be replaced with something else like change in value or price.
This is an example for rate of change. Rate of change for interval A is 6 miles per hour. Distance equal to rate time, or D equal to RT. Let's go to example question. So, distance equal to 26 miles, rate equals to 6 miles per hour, and time equal to 2 variable that we are solving now. Let's solve this together. D equal to RT mean 26 equal to 60 because we need to find T. Then 26 divide 6 equals 60 divide 6. So the answer will be 4.33 equals T. It means time equals to 4.3 hours. It will take Karen just a little over 4 hours and 15 minutes to run a marathon at constant rate of 6 miles per hour.